Are you ready for functions? Some more functions. Today we're going to look at a few questions from past papers as a follow-up to part 1 of the same topic. But before we do that, there's a few extra concepts that I would like to discuss with you. Now we know that when we deal with functions, we sometimes encounter problems on transformations. It is important for you to know and understand and be able to identify the different types of transformations that can occur on functions. First of all, remember our function as f of x. If we consider it as f of x, there are a few things that can happen to f of x. For instance, we could have f of negative x. Now this is slightly different because we've introduced the negative. And if you notice, the negative is multiplying x. It means that all the x values in our function are going to be multiplied by a negative. This is equivalent to reflecting on the y-axis. This represents a reflection on the y-axis. That's number one. Number two, you could have negative f of x. This time around we're multiplying f. Please remember that f is the same as y. What it means is that we're multiplying all the y values of our function by a negative. Now this is equivalent to reflecting on the x-axis. Reflecting on the x-axis. Thirdly, we could have the scenario f of x plus a. Now this is equivalent to shifting. It's a translation. We're shifting our graph. Now this may sound contradictory, but if you have plus a, we are shifting to the left. Keep that in mind. When you're adding, you're shifting to the left. And likewise, when you're subtracting, you're shifting to the right. So negative a implies we're shifting our graph to the right by a units. This applies to trig functions as well, by a units. We could combine two of these transformations. Take, for instance, this scenario where we have f of a minus x. Very interesting scenario. There are two transformations here, as you can probably see. The first transformation is the negative. Now, this is the same as the negative we spoke about there in 1. So what we're doing, we reflect. Since it's negative x, we're reflecting on the y-axis. And then the second transformation that we have now is the a. Probably you can see that this is positive a. So basically adding a, which is equivalent to number 3 here. So step 1, reflect on the y-axis. Then step 2, we shift Since our A is positive, we're shifting A units to the left. Remember, when it affects X, it always does the opposite of what it seems. Now, there's one more scenario I would like to present here. Let me call it number 6. If you have f of x plus a, remember we said f is y. So we are adding a units to y. This is equivalent to shifting our graph a units upwards. Similarly, if it's a minus, a would imply we're shifting a units downwards. If we had time, I could give you some illustrations of this, but I'm sure you can check your textbooks. They might have a few examples of this. Now, it's important that you familiarize yourself with all these possible transformations that you can get. You may encounter them in problems. Now, having said this, one other aspect which I would like us to talk about is the domain and range. Now remember, domain refers to x values. And then range is y values. However, these are not just x and y values. These are values where the function is defined or where the function exists. And we basically have 4 functions. Now let's look at a parabola. For a parabola, generally we say that our domain is x element of R, meaning our parabola exists for all values of x, generally. Now, if you analyze a parabola, whether the value of a is positive or the value of a is negative. Remember, here we said a is greater than 0 and a is less than 0. Now, you can see that your parabola exists for all possible values of x that you can think of. So for x, real number, your parabola will always exist. If I were to draw a vertical line at any point there, vertical line from the x-axis will always coincide with the parabola at one point or the other. Now remember, these arrows were saying etc. So from any point on the x-axis, you can draw a vertical line that will touch your parabola. Hence we say all real numbers. That is our range. our domain. What about the range? The range of a parabola is dependent on the turning point. Now I can tell you that whenever a is greater than 0, your range is going to be y greater than the y value of the turning point. You have to calculate the y value of your turning point. And then y will be covering all real numbers that are greater than the y value of the turning point. However, for a less than 0, your range will be y less than or equal to the y value of the turning point. And y will be all real numbers. The next type of function would be our, let's take a hyperbola. Now you remember that a hyperbola has got two asymptotes. And it's important to remember that on your asymptotes, the graph does not exist. And this horizontal asymptote we said is y is equal to q. And this one is x is equal to p. Your domain is given by x, element of R, all real numbers, but x must not be equal to p. The range y is all real numbers except q. Thirdly, we look at the exponential function. Please refer to part 1 of this video for details on these types of functions. If you remember your exponential function, this is one example of an exponential function. Sometimes it will appear as this, as an increasing function. Now this horizontal line is our asymptote. Which is given by the equation y is equal to q. Now as you can see, if you draw a vertical line from the x-axis, you will always encounter the function. From anywhere on the x-axis, you will encounter the function. Now remember, the function continues in that direction. So we can say that our domain is x element of R. Means x is all real numbers, no exceptions. And then our range, now if we had, let me just superimpose a y-axis here for argument's sake. Now, if I were to draw a horizontal line on the y-axis at this point, you can see that we'll never encounter our graph. any point along these lines that I'm drawing. However, as soon as I pass the asymptote, I'm going to encounter our graph. Every time I draw a horizontal line, I'm going to encounter my graph. So every time I encounter my graph, it means the graph exists for those values of y. However, when I do not encounter my graph, it means it does not exist. It's not defined at those points. Now, our graph is above the asymptote. So our range would be all y values, y element of R. However, it must be the values of y which are greater than q. Take note that I'm not writing as greater or equal to, because our graph will never touch the asymptote. It's not defined the asymptote. However, sometimes the exponential is below the asymptote. Perhaps it can be like that. Now, if this is our asymptote, y is equal to q, it means our range would be y element of R, all real numbers, which are less than q. The last type of function, it's not very common for them to ask you, but it's a straight line. It's rare that they ask you for domain and range, but in case they do, let's suppose we have a straight line like this one, a random straight line. It's easy to see that any vertical line drawn will encounter our straight line. We're drawing it from the x-axis, by the way. So it means our function exists for all values of x. So our domain would be x is all real numbers. Same applies if we draw a horizontal line. It's going to touch our straight line at some point. So here I can say the range is y element of R. This is always the case, except for the two cases where your straight line is parallel to the x-axis. The straight line is y is equal to k. Then here we can see still our domain is all values of x, because we will always encounter our graph. So domain will be x element of R, and range will only be y is equal to k. I'm sure you can figure out for the other scenario.